Good morning, all of you. In the previous class, in the first class, I have discussed about the viscosity and the coefficient of viscosity. We have discussed coefficient of what is the coefficient of viscosity, and what is the unit and dimension formula. We have discussed. Okay, so in this class, we will discuss about the Stokes law. We will discuss about the Stokes law in this particular period. Okay, so before going to Stokes law, what are the effect of viscosity? What are the effect of viscosity? First of all, we will discuss. Then after we will go to the Stokes law. Okay, so what are the effect of viscosity? First, it is on the page number 604 on your book. Okay, so what are the effect of the viscosity? First effect is the coefficient of viscosity depends upon the nature of the fluid. Okay, the coefficient of viscosity that depends upon the nature of the fluid, not depends upon the area. That means one the formula is there, that means viscous force F equal to eta a dv upon dx. Yes or no? So this is the formula, but coefficient of viscosity, that means eta equal to f into dx divided by a into dv. Okay, so eta is the coefficient of viscosity. Okay, and uh, eta equal to f into dx divided by a into dv. This is the formula, but what factor it depends upon? It depends upon, first factor is it depends upon the nature of the material. Okay, if the material is more viscous, if the material is more viscous, that means coefficient of viscosity will be more. Okay, that means if you're taking the between the water and glycerin, glycerin glycerin, or you can take honey also. In that particular two things we have taken, in the water the viscous force will less, as it is having the less density, and honey having the viscous force will be more in the particular honey. That means viscous force will be more here, and viscous force will be less in the particular well water. Okay, so first effect is, that means it depends upon the nature of the fluid and not depends upon the area. Okay, so second point, what is the temperature? That means the viscosity of the liquid it decreases sharply with the rise in temperature. If you increase the temperature of the fluid, if you increase the temperature of the liquid, the viscous force also liquid the viscous force also increases. Okay, that means viscosity of the fluid decreases the decrease rise in temperature. That means if you increase the temperature, like water having the 20 degree centigrade, water whatever the temperature is 20 degree, water having the whatever the viscosity, that means coefficient of viscosity, if it is some value, that means 1.5, then at 40 degrees centigrade, that means in that particular temperature the viscosity will be less. That means it is nearly equal to 1.0. Okay, so that means if the temperature will increase, then viscosity will decreases. So second point, viscosity of the liquid decreases sharply with the rise in temperature. Okay, and becomes zero at the boiling temperature. If the water is boiling at that particular boiling temperature, water having the viscosity or any substance having the viscosity will be zero. Okay, so third point, effect of pressure. Pressure means with the increase in pressure, the viscosity of the liquid generally increases also. That means if you increase the pressure also, the viscosity increases. If you increase the temperature, the viscosity decreases. Okay, so fourth point, effect of density. Density means the viscosity of the liquid increases with the increase in density. I have already told you, that means water having the higher density and water having the low density as compared to glycerin. So density, what viscosity is less in water, and glycerin the viscosity will be more. Okay, so glycerin will be more viscous as comparison to water. Okay, so that means so if the substance having the low density, in that condition viscosity will be less. If the substance, if the liquid having the high density, in that condition viscosity will be more. Okay, so then comes to Stokes law. Stokes law, one law that is given on the base of the viscous force. On the viscous force, one law is given, that is called the Stokes law. Stokes seen that experimentally, he has seen that if a small sphere of radius r, if a small sphere we have taken, that is having the radius r, is moving with a velocity that is called the terminal velocity. If I'm just making the figure just to see that this period and next period also we will take. Okay, that means the fourth and fifth period we will take. So Stokes law. What the Stokes law says that if in a liquid, in a liquid, the liquid is like this, okay, and if a spherical ball we have taken and having the radius r, spherical body having the radius r, and it is moving with a what the velocity of v velocity, terminal velocity v, through a perfectly homogeneous medium, or it is a liquid in of infinite extension, then viscous force acting, whatever the viscous force that is acting on the sphere, that means what are the what viscous force opposing force, that is how what will be it is F proportional to eta, F proportional to R, A proportional to V. That means a viscous force that depends upon the three factors. First one is the eta, second one is the R, and third one is the V. V means the terminal velocity. It is the terminal velocity, or it is called the normal, whatever the velocity the spherical body have, that is called the terminal velocity. Okay, and this is the radius of the particular spherical body. This is the radius of the spherical body, and this is the velocity of the particular fluid. And it is a coefficient of viscosity. Coefficient of viscosity. Okay, so F, that means the viscous force that depends upon three factors. First one is the eta R V. According to Stokes law, according to Stokes, the viscous force that is acting on the liquid, if a spherical body is falling with a velocity of V and having the radius of R, then what is the viscous force that is falling? F proportional to eta, A proportional to R, A proportional to V. So F, if we equalize, that means F equal to some constant k into eta r v. Okay, and that k is called as the Stokes constant, or it is what is the value of the k? K is having the value 6 pi. You can, I'm writing here 6 pi eta r v. This is the Stokes law. F equal to 6 pi eta r v. F equal to 6 pi eta r v. This is the law given by the Stokes. The viscous force, whatever the viscous force that is acting on the sphere, will be F equal to 6 pi eta r v. Okay, so 6 pi is a constant, and it is experimentally found that. So what is the constant value? 6 pi, and eta r v. Dimensionally also you can prove this particular law also. Okay, so this is the what Stokes law. So in from the Stokes law, we can also derive what is the value of eta. Eta will be how much? F upon 6 pi RV. Yes or no? So if you want to find out the eta, eta will be how much? Eta will be F divided by 6 pi R into V, 6 pi R into V. Okay, so this is the what coefficient of viscosity of that particular medium. Medium means whatever the liquid is, that is in that particular liquid the ball is or spherical body is falling. We can find out the coefficient of viscosity of that particular liquid by the formula eta equal to F upon 6 pi RV. If you know the radius of this particular spherical ball and velocity, how much velocity the body is falling, then and also we know the viscous force. What is the viscous force? Then we can find out the eta also from that particular formula, eta equal to F upon 6 pi RV. And also we can derive the dimension formula from this equation also. That means how much will be the dimension formula? We have already known that eta having the dimension formula, but also from this formula also we can derive eta equal to F upon so F means MLT minus 2 divided by RV. R means L, okay, and V means LT minus 1. Okay, so MLT minus 1, this is a constant 6 pi, no dimension formula. MLT minus, that is the dimension formula of force. Okay, and LR means it is a radius, so it is a length, it is a type of length, so we have written L. And V means velocity, terminal velocity we have taken, so that means LT minus 1. Okay, so we can calculate, and the dimension formula will be ML minus 1 T minus 1. This is the dimension formula of eta. This is the dimension formula of what? Eta having the dimension formula this much. Okay. Then comes to two conditions are there. Two conditions are there. How can you find out the terminal velocity? And what is the effective downward force? If a body, if a ball or spherical ball is that is the falling, in that condition, two conditions are there. What are the two conditions are there? Just I'm deriving the seed. If the ball is falling like this is the what the liquid, okay, and the ball is in this particular, the ball is having the radius r, radius, okay, and it is coming with the velocity of v, velocity that is v, okay. So we have to find out what is the we know that if the some ball or any body that is falling in that particular condition, one upthrust is also acting, that is upward. Okay, upthrust means it is a what upward force of the particular liquid molecules that is also acting towards upward direction. Okay, that is the upthrust. And the liquid, whatever the ball is there, so if the ball is the falling, ball is also having somewhat falling, as it is falling downward, so it is also having some weight of the particular ball also there. So we have to find out the effective downward force. What is the effective downward force? We have to find out. Okay, then how can you find out the effective downward force? First is there, we know that the formula is that effective downward force is equal to effective downward force equal to how much? That means if the ball is falling, that means weight of the ball minus that means whatever the upthrust that is there of weight of the ball minus upthrust, is or no? So weight of the ball means what? Mass of the ball into gravity, is or no? Mass of the ball into gravity, okay, and minus mass of the ball into gravity. Mass means what? Volume into density, volume of the ball into density. Density means we have taken rho into g, v into rho into g, okay. And here minus that means the liquid also having somewhat volume, that means v into it is also having the formula mass into gravity, okay. That means whatever the upthrust is, that is also type of force. Upthrust means it is a type of upward force, okay. So that means it is also having some weight, that means mass into what mass into gravity. So mass also you can replace the volume into density into density means here density, we have already mentioned density of the liquid, density of the body is rho. Here we have to mention the density of the liquid, that is the sigma, okay, sigma into g, okay. So that means v into sigma into g, okay. So if you take the common, that means if you take the what v and g as the common, then what will remaining? Rho minus sigma. So rho is the density of solid, and sigma density of liquid, okay. So you can take density of the spherical body, okay. So density of the spherical body, that is volume into the v into g, you get a common, then what will remaining? If I am writing here also v into g, you can take common, then rho minus sigma, okay. Rho minus sigma, it is the value, that is the effective weight, okay. So you know that volume means what? 4 by 3 pi rq. If the spherical body having the radius r, so it is the formula is that 4 by 3 pi rq into g into rho minus sigma, rho minus sigma, okay. So this is the effective downward force, okay. Then comes to, we know that the whatever the viscous force, whatever the viscous force that is acting also upward, so it is what is the value? That means I'm just writing 4 by 3 pi rq into g into rho minus sigma, rho minus sigma, this is sigma, okay. So rho is the density of the, we have mentioned also, density of the spherical body, and sigma is the what? Density of liquid. Okay, so 4 by 3 pi rq g into rho minus sigma. Okay, so if you compare, that means we have already know that the viscous force F equal to, this is also one type of what, this is which force? This is called the effective downward force. This is called the what? Effective downward force. And also we have know that the Stokes law, according to Stokes law, F equal to 6 pi eta rv. F equal to 6 pi eta rv. Okay, this you put the equation 1 and this you put the equation number 2. Okay, so this is the equation number 1. We have find out on what the effective downward force. It will be 4 by 3 pi rq g into rho minus sigma equal to F equal to 6 pi eta rv. Okay, so this is also one type of viscous force that is also acting on the particular spherical body. So as the left hand side is equal, so right hand side also can be equal. So that means 4 by 3 pi rq into g equal to 6 pi eta rv. So here whatever the v is there, that is called as the terminal velocity. Terminal velocity. Okay, so it is called as terminal velocity. So we can find out, we can write down the v equal to how much, this v terminal velocity. We have to, if you want to find out the terminal velocity, then if this will be equal to this, then v we can find out by what, if you divide this term with this particular denominator, so we can find out the v also. Okay, so v will be how much, the v means the terminal velocity, it will be nearly equal to 2 by 9, or we can divide this to 4 by 3 pi rq into g into rho minus sigma divided by rho minus sigma divided by 6 pi 6 pi eta r v, 6 pi eta r. Okay, so if you just calculate, so it will be how much, it will be 2 by 9 r square, 2 by 9 r square into rho minus sigma. Okay, rho minus sigma into g divided by eta. So this is the value of what, terminal velocity. This is the value of terminal velocity. Okay, so if the Stokes law question is asking about the Stokes law, so you have to, question will be asked, that means what is that Stokes law, define what is Stokes law, state and explain what is Stokes law. Then after, and also find out the derivation for the terminal velocity of the fluid. Okay, you have to find out 4 marks question or 3 marks question it will come. Then there are two application of Stokes law. Stokes law says that if some body is falling, if some body is falling inside a liquid, that means whatever the velocity the body have in the top position, the velocity will increases in the downward position, the velocity will automatically increases. The same thing also happening in the case of raindrop, as well as raindrops also. Raindrops means if the raindrop is falling, in that also case you can see that the, if at the topmost position the rain, whatever the drops, the raindrops are there, raindrops having the less velocity at the top position, and when it comes to the downward, that means when it comes towards the earth, its velocity will automatically increases. Okay, so it depends upon the g also, it depends upon the what, the density of the two layers, that means the body, the raindrops, as well as the normal atmosphere, whatever the density of the atmosphere also. Okay, so this also has the application. Then comes to today we'll discuss the theoretical part, tomorrow we'll discuss the numerical of this particular Stokes law and equation of continuity. These are all classes, that means whatever we are discussing, Stokes law, Parsley formula, Bernoulli theorem, these all things are very important. Okay, so attend the class properly. In the particular liquid chapter, these things are very important. Okay, so question will come from this particular topic. Then comes to flow of liquid through a pipes. Flow of liquid through pipes. Or one scientist name is that's called the Parsley. So Parsley formula. One formula is that is called the Parsley formula. That means Parsley found out that how much, what is the, what if a liquid is flowing through a pipe in that particular condition, what is the, what volume of the liquid for, with respect to time we have to find out. That means Parsley found that experimentally he has found that if a liquid is flowing through a pipe, so he has found that the volume of the liquid, the volume of the liquid per second, the volume of the liquid per second, that means it is written as q equal to volume of the liquid per second. Okay, so Parsley found that one, he has derived one formula. So that formula says that the volume of the liquid per second, that is dependent on the three factor it is depending. First one is the coefficient of viscosity of the liquid, second one is the radius of the pipe, and third one is the pressure gradient. Third one is the what? Pressure gradient. Pressure gradient means we have discussed that dv upon dx, that is called the velocity gradient. Same p upon what, l, that means that is called as the pressure with respect to length. Okay, okay. If if the quantity with respect to length we have taken, that is called as the, that's called the gradient. We have to mention the sign gradient. Okay, so pressure gradient means pressure with respect to length, that means p upon l. Dv upon dx, that is called the velocity gradient, or you can v upon x also you can write. Okay, so this is called the pressure gradient. So that means according to Parsley formula, Parsley, what the Parsley told that, Parsley told that if a liquid is flowing through a particular pipe, okay, if a liquid through a pipe that having the uniform area, and in that particular condition, the volume of the liquid, what is the volume of the liquid? The volume of the liquid per second. Per second, if you are finding out the how much volume of the liquid is passing per second. Okay, so that depends upon three factors are there. First one is the, it is depends upon the coefficient of viscosity of the particular fluid. It depends upon the coefficient of viscosity of the particular fluid. Second one, it depends upon the what, radius of the pipe. Whatever the pipe we have considered that having the some radius, so it depends upon the radius of the pipe. Third one is the pressure also, it depends upon the pressure gradient, or it is called as the pressure per unit length. So so it depends upon, so q depends upon three factors. So it is directly proportional to eta. Okay, it directly proportional to eta. Second one is the r, and third one is the p upon l. P upon means pressure gradient. Okay, so it depends upon three factors. If you equalize this all these things, that means g upon t equal to some constant k, is or no, some constant k. Okay, so this is the volume per second, volume of the liquid per second. How much liquid is flowing per second, if you're finding out. So K into eta. Eta means coefficient of viscosity. If you want to find out the exact value, how much it is depending. So that means we have to derive the formula. We have to derive the formula. So how can we derive the formula? K into eta to the power alpha, or you can write ABC also. A or R to the power B, and P by L to the power C. ABC value we have to find out. Dimensionally, we have to find out the value of A, B, and C. Then we can derive the formula also. Okay. So that means so LHS. What is the dimension formula of LHS? I am writing. What is the dimension formula of LHS? LHS having the dimension formula, that means Q equal to volume upon time. So the volume equal to LQ divided by time equal to T, or you can write T also. So it will be L3 T minus 1. This is the left hand side having the dimension formula this much. Okay. Then comes to right hand side. What is the dimension formula of RHS? Dimension formula. This is the dimension formula of LHS. Dimension formula of RHS will be how much? K is the constant. K is the constant, and eta. Eta means M L minus 1 T minus 1. Okay, and to the power A, and R to the power B. R means L to the power B, and P by L. P means it is a pressure. Pressure. What is the dimension formula of pressure? Who can tell me what is the dimension formula of pressure? Pressure means it is a force upon area. Also, you can find out the dimension formula like this. So pressure equal to force upon area. So the force will be mlt minus 2 divided by L square. So it will be ml minus 1 t minus 2. Okay. So you can put ml minus 1 t minus 2 per unit length. Per unit matlab, that means you have to divide the L also. So e to the power c. Okay. So this is the dimensionally proof of. So this is the dimension formula of RHS and this is the dimension formula of LHS. Okay. So here just see that K into m to the power a, m to the power a, L to the power minus a, and T to the power minus a. And L means what is the value of L to the power b. Okay. And here m to the power c, L to the power if L will go upward, then that means the numerator, then what will happen? L to the power minus 1, it is also minus 1, so minus 2, so L to the power minus 2c, and T to the power minus 2c. Okay, so this is the value of what? RHS. Okay, so then just see that, so K into so if you equal it LHS means how much? L3T minus 1. Okay. If you equalize the both the things, then what will happen? Here m will be how much? M here m power is, you can write also power also. M to the power a. Okay. If you just add, so then a plus c. A plus c, because here also base m is there. Here also same base. So you can add the power also. So a plus c. Okay. So L will be how much power? Minus a plus b minus 2c minus 2c. Yes or no? So third t power is minus a minus 2c. T to the power how much? Minus a minus 2c. Okay. So here power is how much? M to the power 0, L to the power 3, T to the power minus 1. Okay. So if you just equate, that means if the two base are same, here also m and here also m, and both sign are equal, then what will happen? Then you can write also what a plus c, that means you can write m to the power a plus c equal to m to the power 0. So we can write a plus c equal to 0. First equation number 1. Then second equation will be how much? A minus a plus b minus 2c. Here L power is minus a plus b minus 2c. Here L power is 3. So we can write equal to 3. Equation number 2. Third equation will be minus a minus 2c equal to minus 1. Minus L minus minus 2c equal to minus 1. So you have to prove this from the equation. Here take the third, this is the third equation and this is the first equation. Just to add the two equation, third equation is how much? A minus 2c equal to minus 1. Just to add the two equations, then what will happen? A will be cancelled and c plus minus 2c, that means minus c it will be. Yes or no? So minus c equal to minus 1. So c equal to 1. C equal to how much? C equal to 1. Okay, so if c will be 1, then if c will be 1, then put the value of c in the equation. A plus c, you know that a plus c equal to 0. So c equal to 1, that means a plus 1 equal to 0. So a equal to minus 1. Okay, and the third equation, that means a minus a plus b minus 2c equal to 0. Sorry, minus equal to 3. So if you put a equal to minus 1, so that means plus a minus 1 minus plus, so b we have to find out, and that minus 2c, so it is the 1. So 1, so b will be how much? 1 minus 2, that is the minus 1 equal to 3. So implies b equal to 4. B equal to how much? 4. So we have found out how much we have. A equal to minus 1 and this b equal to 4 and c equal to -1 from this particular equation. A equal to -1, b equal to 4 and c equal to -1. Okay, got it? Then if we put the value in this particular equation, then what will happen? So a equal to -1 and b equal to 4 and c equal to what? C equal to -1. Okay, if we put this in the equation, then what will happen? Q equal to some constant k, we have taken eta to the power a, and r to the power b, and p by l to the power q we have taken. So k into eta means eta to the power a means -1, r to the power b means p to the power 4. Okay, and p by l to the power c means how much? -1. Okay, p by c means c to the power also -1. So we can write like this. Okay, so if we just put it, then what is the value of q equal to how much? K p r to the power 4, k p r to the power 4 divided by eta into l. This is the value of q. This is the value of what? Q. Okay, so if we have put that a equal to c equal to how much? C we have find out to c equal to c equal to 1, that means -1. Okay, a equal to -1 and c equal to 1, sorry, c equal to 1, that means this value will be 1. Okay, so k p r to the power 4 divided by eta into l. This is the value of what? This is the value of Parsley formula we can write, or you can write the volume of the liquid passing per second. Per second, how much volume of the liquid that is passing, you can find out from this particular formula. Okay, and if you you can write this formula as this method also, like this. You see that q equal to k k. Also, you can write this formula. We can write also this method also, like P divided by 8 eta L, 8 eta L divided by P divided by 8 eta L divided by pi r to the power 4. Pi r to the power 4 also you can write. Okay, so if we are writing like this, okay, if we are writing like this, that means k value is here, the value is the k, that means q equal to k. What is the value of k? K value is the pi by 8. Pi by 8 p r to the power 4 divided by eta into l. This is the value of q. Okay, so we can write this formula like this also, we can write. So if we are writing like this, so this value, this means 8 eta L divided by pi r to the power 4. This is called as the viscous constant. This particular value 8 eta L divided by pi r to the power 4, that is called as the viscous constant. Viscous constant. Okay, 8 eta L divided by pi r to the power 4, it is called the viscous constant. So you can write like this, q equal to p divided by viscous constant. Viscous constant. Q equal to p divided by viscous constant also you can write by replacing the particular fundamental quantity. Okay, so what is the value of Parsley formula, or what is the, if the question is coming, that means what is the derive the equation of for Parsley formula, or derive the what is the amount of flow of liquid that is the passing through a particular pipe. That means if a question is asking uh, calculate the volume of the liquid per second, how much liquid that is passing per second through a pipe, you can calculate by this particular formula. Okay, then comes to one equation is there, that is called the equation of continuity. Okay, numerical, we will do the numerical and base the particular this formula in the next class. That means tomorrow class we will discuss the numerical. Today we will discuss the theoretical topic, and after tomorrow numerical we will discuss. Okay, so then comes to next equation, that is called as the equation of continuity. Equation of continuity. Equation of continuity. So what is that equation? Okay, so equation of continuity. If a liquid is flowing through a, okay, if the liquid is flowing like this, if a liquid is flowing like this, okay, that means here the liquid is flowing through a streamline flow, it is flowing, and having the different area. Here the area is different, here the area is also different. Okay, and as it is a narrow cross section, so velocity will be also more. So here the velocity is v1 and here the velocity is v2. Okay, and this is the a point and this is the b point, and you have find out that time is here delta t, here also time is delta t. Okay, so so we have found out one equation that is related to the that is called as the equation of continuity. What is that equation means? What is that equation means? Okay, so equation of continuity says that that means if a liquid, that means that liquid should be incompressible non-viscous fluid, or liquid that is flowing through a streamline flow. If that particular liquid is flowing through a streamline flow means what? The streamline, if a liquid is flowing through a streamline flow, in that condition, the whatever the velocity of the previous particle, the same velocity, that means the velocity throughout the flow will be remain constant. Velocity throughout the flow will remain constant. What is the velocity? If the velocity of this particle is 5 meter per second, here also having the same velocity 5 meter per second. Okay, so if we will change the area, then velocity can also differ. So if the liquid is flowing through a streamline flow, in that condition, so equation of continuity says that streamline flow, then the product of area of cross section and the velocity of the fluid at the same at the every point in the tube. If the product of velocity and area will be same throughout the tube, it is will be same. According to equation of continuity, what the equation of continuity says that if a liquid is flowing through a, if a liquid means what, which type of liquid? It is an incompressible non-viscous liquid that is flowing through a streamline flow. In that condition, the product of what? Area into velocity of the liquid. Area of cross section into velocity of the liquid is same at every point in the tube. In the tube, it is the same at every point. Okay, so if the liquid is flowing like this, then here the area, if we take in the area, that means here the if the area will be, here the area will be a1 and here the area will be a2, different area we have taken. Okay, so we have to find out, we have to derive the relation. That means what we have to derive? Av remain constant. Av remain constant. A means what? Area, and v means velocity. Okay, if we find out the product of the a and v, that will remain constant throughout the flow. Okay, we have to find out, we have to derive the relation. Tell me, first you know that the mass equal to, you know that density equal to, one formula you have know that density equal to mass upon volume. Yes or no? You have know this formula, that means the density equal to mass upon volume. Yes or no? So if you want to find out mass will be how much? Volume into density. Volume into density. Yes or no? Volume into density, that will be the mass. Yes or no? So if we want to find out, so how much mass, that means that will be passed in this particular a point, how much liquid, that is how much number of liquid that is passing. Okay, if you want to find out, then what is the value? We know that mass equal to volume into density. Yes or no? Density of the liquid. Okay, so volume means what? Volume means area into length. Yes or no? Area into length into density. Okay, so area means Area means how much? Here we have taken as we have considered the M1. M1 means what? This is the mass of the liquid that is passing at a point. Mass of the liquid. I am writing. M1 means what? Mass of the liquid. Mass of liquid passing at a point. Okay, that we have considered M1. Okay, mass of the liquid that is passing at a point. Okay, so M1 is how much? M1 will be how much? Area A1. First we have considered the area. Here we have considered the area A1, and here consider here the, that means we can also take capital A also. So capital A1 and into length. Okay, length, the length we have taken L. Okay, L1. Okay, and the density means rho, we can consider. Okay, so here it will be how much? A1 into length. Length means what? Just I am writing another formula also. You know that velocity equal to displacement upon time. Yes or no? Velocity of the liquid equal to displacement upon time. So if you want to find out displacement equal to how much? Velocity into time. Yes or no? Velocity into time. So in place of length, we can write it v1 into delta t also. Delta t means whatever the time taken. That is called the delta t. Whatever the time taken to complete that particular liquid, if the liquid is passing in that condition, what is the time taken? That is called the delta t. Okay. So delta t is the time, and a1 v1 delta t into rho. A1 v1 a1 v1 delta t into rho, that is called as the water mass of the liquid at the a point. Similarly we can find out m2 equal to how much? A2 v2 delta t into rho. A2 V2 delta T into rho. Rho means the density of the liquid. Okay. So A1 V1 delta T into rho. Here M2 equal to A2 V2 delta T into rho. Okay. At the B point. Okay. We have to prove that AV means what? A means area into velocity of the liquid remain constant throughout the flow. That you have to prove out. How can you prove that? Just see that. So we have found out m1 equal to this much, m2 equal to this much. Okay, so m1 means what? The whatever the mass of the liquid that is passing at a point, at a, here the liquid is flowing like this and through a streamline flow. So a point, whatever the liquid that is flowing, that is we have considered m1. Okay, so according to conservation of mass, whatever the mass of the liquid that is passing here, same mass also will be passing through that particular point. Okay, so according to conservation of mass, m1 equal to m2. Whatever the mass of the liquid that is passing here, the same mass will be also passing at that particular point. So as m1 equal to m2, so equation 1 and 2 also will be equal. So a1 v1 delta t into rho equal to a2 v2 delta t into rho. So rho delta t can be cancelled from both sides. What is the remaining? A1 v1 equal to a2 v2. A1 v1 equal to a2 v2. So a1 is the area of the liquid. Okay, area of the particular, what is the through is the liquid is the passing area into what? Velocity of the liquid. Okay, so area into velocity equal to first what? At the a point, a1 v1 equal to a2 v2. That means ab remain constant. We can write also ab remain constant. That is called as the equation of continuity. Equation of continuity, I'm again repeating. Equation of continuity says that if the liquid is passing through a streamline flow through a particular pipe, the liquid is passing. Okay, so we have seen that the product of area into velocity of the liquid throughout the flow, it will be remain constant. Throughout the flow it will remain constant. Okay, so this is called as the equation of continuity. So if the velocity of the liquid will be smaller, then wider will be the pipe. That means if the pipe will be wider, just you have seen that if the narrow pipe will be there, the pipe will be very narrow. In that condition, velocity of the liquid will be much more. Yes or no? And if what the pipe having the wider length, in that condition, velocity of the liquid will be less. Okay. So in that condition, we have find out that area into velocity of the fluid, that will be remain constant. Okay. Then comes to these are called the equation of continuity. I'm again repeating the what is the equation of that is very important. What is equation of continuity? Equation of continuity says that if a liquid is passing through a streamlined flow through a pipe or any surface area or any particular pipe it is flowing, in that condition, product of area into velocity, product of the area into area per section into velocity, the liquid remain constant throughout the flow. That is called as the equation of continuity. So av remain constant if the velocity of the liquid will increases. If the velocity of the liquid, that means the pipe should have wider area. Okay. If the pipe should have the, that means if the pipe having the less area, in that condition the velocity of the liquid will having the greater velocity. Pipe having the greater area, that means wider area, in that condition what the liquid having the slow, that means the liquid is moving with a slow that means less velocity. Okay. So these are two conditions are there. Then comes to, we will discuss the different energy of the flow of liquid in the next class. We will discuss, and after that we will discuss the Bernoulli theorem. Okay. So Bernoulli theorem also most important question. So if anyone having any doubt, you can ask me. Okay. So equation of continuity says that the area into velocity of the liquid will be product of area into velocity of the liquid will be constant throughout the flow. That means it will remain conserve, or A into B remain constant. Okay. Then comes to the next class. We will discuss about the what? The next class we will discuss about the different energies of the liquid that is flowing. If the liquid is flowing, in that condition, uh, what are the different type of energy will produce? One is the pressure energy, one is the kinetic energy, one is the potential energy. So we will find out the different type of energy that is produced when the liquid is flowing. In that condition, what is the different types of energy that will produce? We have to find. Okay. Then also Bernoulli theorem. Bernoulli theorem, one of the theorem that is Bernoulli is one of the scientists that